Some engineers might have a strong personal preference for 1-1/2-inch conduit based on their past experiences or previous projects. Perhaps they encountered issues with smaller conduit sizes in the past, leading them to favor the larger size as a precautionary measure. 1-1/2-inch conduit provides more space for pulling cables, making the process easier and faster, especially when dealing with large bundles of wires or long conduit runs. This can save time and labor costs during installation. While a 1-1/4-inch conduit may meet the current code requirements for the number and size of conductors, a 1-1/2-inch conduit allows for more future capacity if additional circuits or larger conductors are needed down the line. This can prevent the need for costly and disruptive conduit replacements in the future. Some industries or companies may have internal standards that dictate the use of 1-1/2-inch conduit for specific applications or in certain locations within a facility. These standards may be based on historical practices, risk management policies, or specific operational needs. The cost difference between 1-1/4-inch and 1-1/2-inch conduit is often relatively small, especially when considering the overall cost of a project. Some engineers may prefer to use the larger size as a standard practice for convenience, ease of procurement, and to avoid potential issues with fill calculations. While both sizes of conduit meet code requirements for mechanical strength, 1-1/2-inch conduit generally provides greater mechanical protection for the conductors inside. This can be an important consideration in applications where the conduit is exposed to physical damage, such as in high-traffic areas or industrial environments. Some engineers may be overly cautious and prefer to use 1-1/2-inch conduit to minimize the risk of potential code violations, especially in situations where there are complex calculations involved or uncertainty about future changes to the electrical system. This approach can help to ensure compliance and avoid potential penalties or rework. Encountering rigid policies regarding conduit size is something that happens from time to time. It's important to have a respectful and open discussion to understand the reasons behind the decision. If the reasons are not based on code or sound engineering principles, you may be able to present a case and provide alternative solutions that meet the requirements more efficiently. When determining conduit size, it is crucial to consult the National Electrical Code, specifically Chapter 9, Table 1, and the applicable tables in Chapter 3, such as Table 310.15b16 for allowable ampacities of conductors. These tables provide guidance on the maximum number of conductors permitted in a conduit based on the conduit size, conductor size, and conductor type. The NEC specifies fill limits for conduits, which are expressed as a percentage of the conduit's cross-sectional area. For example, for 3 or more conductors, the maximum fill is typically 40%. It's essential to calculate the total cross-sectional area of the conductors and compare it to the available area within the conduit to ensure compliance with the fill requirements. The ease of pulling conductors through a conduit is influenced by several factors, including the conduit size, the number of bends in the conduit run, the type of conductors being used, and the use of pulling lubricant. Larger conduit sizes generally make pulling easier, especially for long runs or runs with multiple bends. When considering future expansion, it's important to assess the potential for increased electrical demand in the future. If there is a reasonable possibility that additional circuits or larger conductors will be needed, it may be prudent to install a larger conduit size to accommodate future needs. Industry standards and best practices can vary depending on the type of facility, the specific application, and the company's internal policies. Some industries may have more stringent requirements for conduit size and type than others. The cost difference between 1-1/4-inch and 1-1/2-inch conduit is generally not significant, especially when compared to the overall cost of a project. However, it's important to consider the total cost of installation, including labor, materials, and potential rework, when making a decision about conduit size. Mechanical strength is an important consideration in applications where the conduit is exposed to physical damage. In these situations, it may be necessary to use a heavier gauge conduit or to provide additional protection for the conduit. Avoiding code violations is a primary concern for electrical engineers and contractors. Using a larger conduit size can help to minimize the risk of code violations related to fill limits, conductor ampacity, and other factors. When selecting conduit size, it's important to consider the type of conductors being used. Different types of conductors have different insulation thicknesses and ampacity ratings, which can affect the required conduit size. The number of bends in a conduit run can significantly affect the ease of pulling conductors. Each bend increases the friction and pulling force required to install the conductors. It is important to minimize the number of bends and to use appropriate pulling lubricants to reduce friction. The use of pulling lubricants can significantly reduce the friction between the conductors and the conduit, making it easier to pull the conductors through the conduit. There are various types of pulling lubricants available, each designed for specific types of conductors and conduit. When considering future expansion, it's important to consider the potential for changes in technology or equipment that may require additional electrical capacity. It's also important to consider the potential for changes in building occupancy or use that may require additional circuits or larger conductors. Industry standards and best practices are constantly evolving, so it's important to stay up to date on the latest requirements and recommendations. This can be achieved through continuing education, participation in industry organizations, and consultation with experienced professionals. The cost of labor is often a significant factor in the overall cost of an electrical installation. Using a larger conduit size can sometimes reduce labor costs by making it easier to pull conductors and reducing the risk of damage to the conductors. Mechanical strength is particularly important in applications where the conduit is exposed to vibration, impact, or other forms of stress. In these situations, it may be necessary to use a rigid metal conduit or to provide additional support for the conduit. Avoiding code violations requires a thorough understanding of the NEC and other applicable codes and standards. It also requires careful planning, attention to detail, and a commitment to quality workmanship. When selecting conduit size, it's important to consider the ambient temperature in the area where the conduit will be installed. High ambient temperatures can reduce the ampacity of conductors, which may require the use of a larger conduit size. The type of conduit being used can also affect the required conduit size. For example, rigid metal conduit typically has a larger inside diameter than electrical metallic tubing, which may allow for a smaller conduit size to be used. The length of the conduit run can also affect the ease of pulling conductors. Longer runs typically require larger conduit sizes and the use of pulling lubricants. When considering future expansion, it's important to consider the potential for changes in building codes or regulations that may require additional electrical capacity. Industry standards and best practices often include recommendations for conduit fill limits, conductor ampacity, and other factors that can affect the safety and reliability of an electrical system. The cost of materials is another important factor to consider when selecting conduit size. The cost of conduit can vary depending on the size, type, and material of the conduit. Mechanical strength can also be affected by the type of fittings used to connect sections of conduit. It's important to use fittings that are compatible with the conduit and that provide adequate support and protection for the conductors. Avoiding code violations also requires proper documentation and record keeping. It's important to maintain accurate records of all electrical installations, including conduit size, conductor type, and ampacity ratings. When selecting conduit size, it's important to consider the potential for corrosion or other environmental factors that may affect the integrity of the conduit. In corrosive environments, it may be necessary to use a corrosion-resistant conduit material or to provide additional protection for the conduit. The location of the conduit can also affect the required conduit size. For example, conduits installed in wet locations may require a larger conduit size to prevent moisture from entering the conduit. The type of equipment being served by the conduit can also affect the required conduit size. For example, equipment with high inrush currents may require larger conductors and a larger conduit size to prevent voltage drop and overheating. When considering future expansion, it's important to consider the potential for changes in energy efficiency standards that may require the use of more energy-efficient equipment and larger conductors. Industry standards and best practices also address issues such as grounding, bonding, and surge protection, which can affect the overall safety and reliability of an electrical system. The cost of maintenance is another important factor to consider when selecting conduit size. Using a larger conduit size can sometimes reduce maintenance costs by making it easier to access and repair conductors. Mechanical strength can also be affected by the way the conduit is supported and secured. It's important to use appropriate supports and fasteners to prevent the conduit from sagging or becoming damaged. Avoiding code violations also requires ongoing training and education. Electrical engineers and contractors should stay up to date on the latest changes to the NEC and other applicable codes and standards. When selecting conduit size, it's important to consider the potential for electromagnetic interference or radio frequency interference. In sensitive electronic environments, it may be necessary to use shielded conduit or to provide additional shielding for the conductors. The voltage drop in a circuit can also affect the required conduit size. Longer circuits with high current loads may require larger conductors and a larger conduit size to minimize voltage drop. The available space for installing the conduit can also be a factor in determining the required conduit size. In tight spaces, it may be necessary to use a smaller conduit size or to find alternative routing options. When considering future expansion, it's important to consider the potential for changes in renewable energy technologies that may require additional electrical capacity. Industry standards and best practices also address issues such as arc flash protection, which can significantly impact the safety of electrical workers. The life cycle cost of an electrical system is an important factor to consider when selecting conduit size. Using a larger conduit size can sometimes extend the life of the system by providing greater capacity and reducing the risk of overheating. Mechanical strength can also be affected by the quality of the materials used to manufacture the conduit. It's important to use conduit that meets industry standards and is suitable for the intended application. Avoiding code violations requires a commitment to ethical behavior and a willingness to report potential problems or violations. Ultimately, the decision of whether to use 1-1/4" or 1-1/2" conduit should be based on a careful evaluation of all relevant factors, including code requirements, industry standards, cost considerations, and the specific needs of the application. A qualified electrical engineer or contractor should be consulted to ensure that the selected conduit size is safe, reliable, and meets all applicable requirements. When evaluating the potential for future expansion, consider not just the immediate needs but also the long-term possibilities for the building or facility. Will there be changes in equipment, technology, or usage patterns over the next 5, 10, or 20 years? Planning for these potential changes now can save significant costs and disruptions later on. Industry standards, such as those published by the National Electrical Manufacturers Association (NEMA), provide valuable guidance on the selection, installation, and maintenance of electrical equipment, including conduit. These standards can help ensure that the electrical system is safe, reliable, and performs as intended. When considering the cost of conduit, it's important to look beyond the initial purchase price and consider the total cost of ownership, which includes installation, maintenance, and potential replacement costs. A slightly more expensive conduit material or size may offer long-term cost savings if it reduces the risk of failures or extends the life of the system. The mechanical strength of conduit is particularly important in applications where the conduit is exposed to extreme temperatures, corrosive environments, or heavy loads. In these situations, it may be necessary to use a special type of conduit or to provide additional support and protection. Avoiding code violations requires a continuous learning process and a commitment to staying up to date with the latest changes and interpretations of the NEC and other applicable codes. Participating in industry training programs and networking with other electrical professionals can help ensure that you have the knowledge and skills necessary to design and install safe and compliant electrical systems. When selecting conduit size, it's also important to consider the aesthetics of the installation. In some applications, it may be desirable to use a smaller conduit size to minimize the visual impact of the electrical system. However, it's important to ensure that the smaller conduit size meets all applicable code requirements and provides adequate protection for the conductors.